Hello, everyone. Thanks for coming to the PyTorch conference, and thanks for inviting me as well. So today I'm going to talk about, can reinforcement learning lead to AGI? For you guys who don't know me, so I'm from Unsloth. So essentially, you can train and run LLMs locally with Unsloth. So we upload models from all around the world, like from large labs, and some of the work that we do includes we upload models to Hugging Face. We actually reached 100 million total downloads on Hugging Face. We have 86,000 models uploaded to Hugging Face trained with Unsloth, and we have 47,000 GitHub stars. Some of the work that we do include we fixed a gradient accumulation bug fix. We do constant bug fixes for all language models from all large model labs. We also work with Hugging Face and OpenAI and GPTOSS, and we help Hugging Face, Google, Meta, and other organizations fix issues and bugs in models. We collaborate with OpenAI during Dev Day to do the 2048 example. So you can do reinforcement learning to solve games and make this work for other examples as well. So, but yeah, back to reinforcement learning. I'm not sure if you guys see this plot. It's quite famous. Is there exponential progress in AI? For example, if you look, so the the graph kind of looks like there is some sort of exponential curve, and then if you instead of using a linear scale, we can then just use a log scale, and you can see the progress in the log scale is in fact linear, but this is actually exponential, right? So the question is, will this exponential trend continue going on? That's the fundamental question. So before that, actually, during around last year, at the very end of last year, there was actually a reasoning jump. So when O1 got released, it was actually quite surprising that actually performance dramatically increased. So if you imagine before the reasoning jump, there was actually, it looked as if models were kind of flatlining in terms of performance. But then suddenly when O1 got released from OpenAI, the whole world kind of oh, okay, this is very interesting. You can actually do reinforcement learning, do more special tricks to make performance much better. And so, over time now, everyone has been doing reasoning models, and this is the next frontier in terms of increasing accuracy. But before this, firstly, I always get asked the question, what is actually AGI? What is the definition of AGI? And so the definition is depends on who you ask. For example, OpenAI's first definition is a system that can do any economically valuable work at human performance or better. And so this is kind of the definition, which kind of what people think about. So the biggest issue, though, is the word any. And so any task is very problematic, because this could mean any single task in the whole entirety of human civilization. You can do computer work, maths, finance, but also hard type work, washing the dishes or doing construction. All of these tasks, this is kind of their definition. Generally, how I like to think about it is I want to remove hard tasks away. Because for example, if you look at ChatGPT, Llama models, Gemini models, they don't actually interact with the world directly. So normally I like to view AGI, the I in the intelligence, as just intelligence. And so if you just constrain the definition to just intelligence, then it becomes slightly easier to define. And so essentially, if AI can just do all intelligent tasks well, with just knowledge work, not hard tasks washing the dishes or something, right? You can't tell ChatGPT to wash the dishes, for example. So it's very hard to tell AI to do that currently. But if you constrain the definition, then we can think about what is RL next. All right, let's just constrain the definition. So firstly, we need to think about what is reinforcement learning first. So the goal of reinforcement learning is we just want to make more good examples higher probability and the bad examples with lower probability. So for example, a very good example is, I always use this example, it's probably outdated by now, but you ask the language model, what is 2 + 2? At the very beginning of the pre-training stage, it will spit out gibberish. So it will say, what is 2 + 2? It might say B, D, apple, cat, dog, I don't know, anything. And then over time, the correct answer is in fact 4. And so when suddenly the model sees 4, you should actually increase the probability of this. And so reinforcement learning essentially forces the model to go towards the correct answer more. And then D and B, you should like penalize the model, right? If it keeps outputting D or B or cat or dog, you want to penalize the model. And so this kind of like, we essentially made a reward function. And so like, essentially what reinforcement learning does is we want to increase the probability of good outcomes and to decrease the probability of bad outcomes. How I like to phrase it is kind of luck is all you need, or actually patience is all you need for reinforcement learning. And so in theory, if you assume the probability of a good answer is at least more than 0, for example, 0.000 recurring 1, then in theory, the RL algorithm should solve your question. If the probability is always 0, then yes, RL will fail. But in general, the probability is always more than 0. And so my phrase is luck is all you need for RL, but patience is probably better. So essentially what this shows is over time when you train our algorithm, the reward will always stay at 0 for a very long time, right? So 0, 0, 0, 0, 0, 0, 0. And then suddenly during the training process, the reward randomly spikes up. And then it's just a very interesting phenomenon during the sampling process of RL that the reward just goes up. And then, like boom, right? You get the reward. And over time, you want to like, over time, the model will be forced to output more correct distributions. So obviously, RL is not that dumb, right? RL is not just going to wait forever and you're just going to get the correct answer. Over time, the bad answers will be reduced, right? The distribution will shift to, make the bad answers less. And then it will increase the distribution for, when the good answers. So RL is not that dumb. So it does have some tricks up its sleeve to make the process much more efficient. For example, like GPDOSS, for the reward function, for example, when you play the 2048 game, when you do RL on this, a good reward is when you win the game, right? When you get 2048. A bad one, when you want to penalize the model, is if it loses, right? If the Python function doesn't execute, if the model just gets 1024 or something, not 2048. And so like there are many ways you can actually reward the models by using special reward functions. A very popular algorithm, that was introduced from DeepSeek R1 is GRPO. So GRPO was used as a more efficient approach to RL. So a very beginning algorithm that everyone was using from OpenAI is called PPO. But the difference between GRPO and PPO is you delete components of PPO to make it much more efficient. For example, you delete the reward model and replace it with a reward function. And so this reward function is not a model anymore. It's just a function which you can say this is a good answer or a bad answer. You also delete other components of the model. And so you just essentially GRPO is an efficient version of PPO. And RLVR is reinforcement learning with verifiable rewards. And essentially, you need to have verifiable functions, such as like maths, right? 2 + 2 = 4. You know the answer, which is 4, and that is the verifiable reward. So you need to have a reward function and some components of PPO, and this becomes GRPO. Nowadays, people have actually changed the reward function approach and include other components, such as LLM as a judge, regular expression checking, executing code to check if it's good or bad, like if it actually executes. And so there's actually many innovations in the reward function area, which people like to do. From my understanding, large labs, essentially, they want to automate the entire process, right? Don't even write the reward functions anymore. It's totally automatically generated by AI. And so the goal of these large labs is to generate, 10 trillion reward functions. And the goal is to reach AGI via this approach, some sort of automated approach to find reward functions. In terms of RL, there's also an interesting factor is there is an inference and training dichotomy. Essentially, you do inference first, and then you train to get the RL algorithm to work, and then you do inference, and then you do training. Currently, most people, the training process takes around 5 to 10% of the training time compute, and inference is 90% of the time. As time goes on, if you want RL to scale even further, then inference might take 99.99% of all time, and training will only take 0.001% of time. And so actually, you need to optimize inference heavily. So for RL to actually reach AGI, you need to make inference much better and faster. So for example, for GPTOSS, for example, we focused a lot of time on trying to make inference faster, not actually training. So actually, interestingly, Unsloth was actually a training framework, but then we found that inference was actually very slow and very not efficient. And so essentially, we were focusing on trying to make inference faster for GPTOSS. And the trick is you need to be careful of having accuracy degradation or other issues during inference. Another very, very interesting factor for reinforcement learning is, in the future, you will have very long context models. And so the goal of for example, Codex and Claude is you can essentially look through your entire code base. But the problem is your code base can be quite long. And if you do reasoning rollouts, it can get very, very long. And so the goal is you need to train your model to have extremely long context. So most models have for example, Gemini has 1 million context length, but you want to extend this to infinite context length. And so for example, DeepSeek released sparse attention a few weeks ago. This is also very interesting. But if you do long context, you have a big problem of the training process. So training, when you do long context, will use a lot of memory. And so we spend a lot of time trying to optimize the training process to reduce memory for long context RL. I'm not sure if you guys saw the recent Dwarkesh Patel podcast, but Andre Karpathy said RL is kind of like sucking supervision bits through a straw. We actually do have a sticker from that is kind of representative of that. But essentially the biggest issue of RL currently is when you train a model using RL, you only get the final reward, right? If you play a game 2048, you can't really. You wait for the game to execute, and then at the very end, it will say the game has won or not won. But then you will miss all the steps in between. And so how do we make the process much more efficient? We should be able to train RL not at the very, very final step, but actually look at the intermediate rewards. This is called process supervision. But the biggest problem with process supervision is now you need humans to annotate the data. Is this process good or bad? Is this intermediate step good or bad? And so that's why large model labs don't want to do process supervision, because it's extremely expensive, right? You'll be hiring as many humans as possible to annotate the data. So I'm not really a big fan of process supervision. However, you can call a language model to actually investigate, is this step good? Is this step bad? And so on. This is the LLM as a judge approach. There is some research papers which show that if you do this approach, your accuracy will increase, but then at some time it actually start decreasing because of reward hacking. So there are some still outstanding questions of whether process supervision via LLM as a judge can work. Another quote that Andre also made is, RL is terrible, but don't misconstrue what he said. The second sentence is everything else is much worse. So if you look on the news, everyone's saying RL is terrible, but they forget the second sentence, which essentially shows that RL at least works, right? So RL is obviously not a very good algorithm, right? So GRPO, PPO, it's not very effective. However, everything else is just even worse. So RL at least works somehow. And another phrase I was during the podcast, OpenAI kind of started off with reinforcement learning, if you knew OpenAI. And then they moved over to the pre-training age using, ChatGPT and stuff like this. And now they're going backwards to reinforcement learning. So it's kind of like a, premature loop kind of thing. They started off with reinforcement learning, they did a hiatus, did pre-training, and now they're going back to reinforcement learning. And the goal of these large labs is to generate these environments for as many industries as possible. For example, pretend you're trying to make a financial bot. The reward function is, increase profit is good, decrease loss is bad, right? And so games, you can also do this. Mathematical equations, you can also do this. So these are special reward functions for these specific industries. And the goal of these large labs is to expand this to all industries in the whole world, right? You want to do weather prediction, you want to do mathematical equations, you want to do programming. And in fact, the goal is to do automating AI research, right? All these large labs want to automate all of AI research. And this is called the intelligence explosion, where essentially by using RL and AI, you can essentially automate all large labs doing research. And so, all these new AI models will all be automated away, finding better transform architectures, finding better data sets, and so on. Another very big issue is for example, during RL, you have to be very careful of the parameters that you set. For example, Thinking Machines released a blog post on law without regret, and essentially they show that if you select the correct parameters, during fine-tuning and reinforcement learning, you can, in fact, only fine-tune a very small amount of weights of the entire model to actually get good performance. So we collaborated with them on this as well. And essentially, you can show that some tasks, if you don't have that many complicated tasks for RL, you can reach the same performance as if you did the total training run. And also, in terms of RL reaching AGI, there's also two schools of thought which I also talk about. So essentially, there are two different types of ways you can think about it. There is one group of people who think that RL accentuates learned or already learned knowledge in the pre-training model. So RL doesn't actually learn anything. And then there is another school of thought which actually they think that RL learns new skills. And so depending on the camp that you are in, you can answer the question, can RL lead to AGI? And so again, remember the quote, RL is terrible, but everything else is much worse. Andre also said that, useful agents and, is kind of a decade away. And then my view is can RL lead to AGI? Most likely at this current stage of time is a maybe. It's possible, right? It's possible if you think about if you get all the tasks in the entire world and then somehow automate them, using automatic reward functions, generate 10 trillion environments automatically. In theory, it could be somehow AGI. So my view is maybe. I'm more 51%. So it's not 49%. I'm more than 50% sure it's possible. It's just you do need a lot of compute and stuff like this. Yeah, definitely check out our other models on Hugging Face, which we upload. And yeah, thank you so much for inviting me. Yeah, thanks. Oh wait, is there questions or is that time or? Okay. Oh, okay. Okay, I talked a bit fast, but okay. Whoops. Okay. Questions? Yes.
Thank you for the great and very fast talk.
Whoops, sorry.
You can give us a lot of time for questions. My question is, you're working on Unsloth, which is run the experiments locally, and RL, which usually takes a lot of compute resources. So my question is, what opportunity do you see, about democratizing RL actually?
Yeah.
And also, how can businesses and corporates use RL? Because RL is very hard to converge and very hard to train. What opportunities do you observe? Thank you.
Yes, great question. So the biggest issue of RL is not actually the training process or the inference step. It's actually the creation of the reward function and the data that you have. So the interesting part of RL is you actually don't need to have data at all. You just need one question. For example, the 2048 game that I was showing, for example, the prompt that we give to the language model is simply, please create a strategy to complete the 2048 game. You only need that one sentence. You don't need anything else. However, you do need to create the environment. You need to create the reward function and so on. So the process has actually shifted from the data collection side to the reward function creation side. And so in terms of large labs, what they want to do is they want to even automate that, right? So all of this is all automated away. The question generation is also automated. The reward function is also automated. Everything is automated. And then finally, even if you automate everything, you do need to make the process much more efficient. So for example, inference, you should use VLLM, SGLang. These are very good, efficient libraries for inference. And for training, for example, we focus very heavily on trying to reduce memory usage. For example, we share weights between VLLM, so we reduce memory usage by 50%. And so if you want to make RL available for all corporations, startups, every single industry, you need to make the process more efficient. And so that's another factor. Not sure if I kind of answered your question, but something like that. Okay. Also, our focus is trying to make the training process more efficient. So essentially, 50% of our user base just uses Unsloth for RL. And so the goal is we reduce memory usage dramatically. We make the inference process much faster. That's kind of what we do. We also make reward functions and you can also check out our notebooks. So we essentially teach people how to do RL, how to make the reward functions, how to do RL properly. Yeah. Thanks. Any other? Yes, yes.
Yeah, thank you. Great talk. I'm curious, what is your bet for the other 49% for AGI?
Oh, so you're saying like, how would why 49 and why do I think 51% kind of?
Oh, 51% for RL, that sounds good, but
Yes.
what is on the other side? What is against RL?
Oh, okay, you're asking me what are like some arguments for not RL working? Okay,
Yes.
there is a research paper which showed that if you use LLM as a judge, so if you automatically if you ask a language model to like to reward intermediate steps by using LLM as a judge, your accuracy actually does increase, but then at some time your accuracy starts decreasing. So actually over time, the LLM as a judge approach actually fails. And the reason is because your model starts doing reward hacking. So for example, if you ask the question to the model, what is 2 plus 2? The answer is 4. And so it might do like some mathematical working out, like, I think, 2 is a number, 2 is a number, addition is some sort of operation, 2 plus 2 is 4, something like that. But then suddenly your model might start reward hacking. Instead of trying to do 2 plus 2 is equal to 4, it might randomly output like gibberish. It might say, so you ask the question, what is 2 plus 2? And then it just says, blah, 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 like actually, blah, 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 blah. And then it just says 4, right? And then the reward is still correct, right? It says blah, 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 but then it says 4. But this whole process is incorrect, right? It's not supposed to say blah, blah, blah. And so my main worry is if you scale this to large runs, you can't actually know if your language model is actually learning or not learning. And your model might randomly like learn gibberish things, but the reward is still correct. And so that's my main worry. So the 49%, like, maybe RL is not going to work, is if we scale RL to some like large training runs and it just does reward hacking. That's probably like the worst case scenario. And then if this happens, well, okay, RL, I don't think so we can reach, it's going to be very complicated to reach AGI with RL. In fact, if this actually happens, then my probability goes to like 0. I don't think it's ever possible then. But for now, my probability is like 51% because it looks like it's working. You could, for example, just stop the training run before it starts decreasing, just stop it. That's one way. Yeah, if that answers the question, but okay. Any other? Yeah.
Yeah. So
Yes.
You talked about GRPO, right?
Wait, oh, okay.
Yeah, you talked about GRPO.
Yes.
Can you talk a little bit more about what are the limitations of GRPO and what's getting improved on top of GRPO?
Yes. So from what I understand, large labs still mostly use PPO. So GRPO was mainly popularized by DeepSeek because they showed that you can actually delete components of PPO, right? Delete the reward model, delete many components of PPO, and essentially it was very efficient. And the trick is you can move the process from PPO instead to making reward functions, making inference, and doing like rollout. And so like it's more, I would say GRPO is actually quite efficient. But the problem of GRPO is there are like many variants, like GSPO, GAPO, DAPO, and stuff like that, Dr. GRPO, and stuff like this. So there is still an active area of research into like trying to optimize the GRPO algorithm. And so like, yeah, I think like Meta released a paper on scale RL or something, like, they showed the scaling laws of RL. That's actually a very good paper, and so you should definitely look at that. I think like GRPO is here to stay, but there needs to be additions to make it better. Yeah.
Hi.
Yes.
So you're talking about the properties of RL that have been discussed recently, like, a low number of bits actually being ingested by the model. But like these are often done with like a very narrow set of use cases, often like math only. And it feels like an extrapolation to all of RL, similar to like how people found you could do pretty well in MNIST by only like classifying a single bit out of the data set. And so I'm curious, with such a massive community of Unsloth users, all these models, what are the use cases where you see users actually getting a lot of utility out of using RL through Unsloth, like, to contrast that with these like relatively narrow extrapolations from like a small number of use cases from these papers?
Yes, that's a great question. So like generally speaking, during RL, only a small amount of bits actually change. So most updates are sparse. And so like the trick is if you want to just focus on one task, it's better to use like some sort of like our training library like Unsloth to do that. But if you're like a large lab and you want to do like, 10 trillion tasks and you want to like shove this into the model, then it's not low rank anymore, right? So like during the RL process, it will be full rank. And so like generally, if you want to do specific tasks, you should use like an efficient training library like Unsloth. If you want to do like large pre-training runs, then I guess large pre-training runs and large RL runs, then it's full updates. Does that, hopefully that, okay, yeah.
Last one.
Okay, last question.
So I have a question on one of the gentlemen mentioned that there is a big gap of how to take RL into industrial setting or into real world scenarios.
Yes.
So you did mention that most of the RL, the biggest way to create your pipeline is the reward function. How easy is it to generalize the reward model? So the industry where RL is not their first job, they are able to define a reward function which aligns with the use case that they are trying to solve. Because I think that is the big step forward to make sure that the industry is able to adopt RL in their working pipeline if the reward function is generalizable.
Yes. Okay, great question. I think temporarily in this current, like maybe in the next year or something, people will try to make custom reward functions. For example, if you're a financial industry, it's not that complicated. The financial industry, you can say like more profit or less profit or something like this. However, the biggest issue is next year, like in my view, we will be moving towards automated reward functions. The environments are automated, the reward functions are automated, everything is automatic, right? You essentially call the language model to generate the tasks, to generate the reward functions, to generate the environments. Everything is generative. And so that's where I see the industry moving towards. So you will never have to you don't need to ever write a reward function ever again. The language model will write it for you. The language model will write make the environment. It will do everything automatically. And so that's also where the large labs are trying to go to, right? They're trying to make 10 trillion environments, 10 trillion reward functions. Everything is automated. And so that's how they're trying to go for. And so like in my view, that's kind of where the industry is headed. So everything is automated. Yeah, if that kind of answers, yeah.
Yeah, of course. Thank you.
Okay. Well, yeah, thanks everyone.